Hi, my name is David. Today we're going to do a LeetCode problem, number 144, binary tree preorder traversal. So we're given the root of a binary tree, return the preorder traversal of its nodes values. So we can look at here, it starts off as 1 as the root, so 1 is root, and that'll be the val. And to the left of it is null, so if it has a null here, and then it goes from the middle node to, it goes from the node to the left, back up to the node, and then to the right. And then it has a 2 here, so we return 2. And then it goes to the left, 3, and then there's no more, so it returns. So that's where it ends. So let's remember preorder. That means we have to look at the node first. We'll go pre, the left to right, and then we go left, and then right. So to solve this, we can use a recursive approach. So it looks like we're returning an array. So we have to create an empty array. So create results array. And that's what we're going to push all the values to and return at the end. Next, we create a traverse function. And this is what we're going to call recursively. And then takes in root, like the same root as this, and then the results array as well. Okay, so inside of this function, first thing we want to do, so it starts off here, we want to push the node into the tree, the results. Push node, and we want to push the value of it only. So node, as we see, that's how we get the val to results. After that, so we push this one, and then we go to the left side. So we call this traverse function to this dot left. So we do traverse, and then this will be the root. So root dot left, and then we call on the right side as well, traverse root dot right. And we forgot, when do we stop here, since we don't have a stop case, and when we get to null, then we stop traversing. So let me put that in the beginning. Actually, if null, return, we just return. So that means we stop. So basically, we're going to traverse down this tree, starting with the node, the val of it. Then we go left. If it's null, we stop calling that recursive approach, and then go up the call stack, back up until we hit where we started. Then we go to the right, and then get that node, and then go to the left and continue on the call stack. So to put it on code, we first create the results array. So let results equals an empty array. And now let's create this traverse function. So const traverse, it will take in the root and the results. And inside of this, we just push the node val to the results. So results dot push node dot val. Next, we traverse on the, we look at the node case first. So if root equals null, return. Great. So let me create some more space. And then we go traverse the left side. So traverse root, change this to root dot left, and then take some results, and then traverse root dot right results. So now we define our helper function, and now we call it traverse. And I just use the same variable names as what we have. So root dot comma results. And lastly, we return results. Great. Great, we got it. So the time and space complexity, since we're pretty much looping throughout the entire tree, it's O of n, and the space complexity will also be O of n, because we are creating a recursive call function, and every time we call this function, it adds to the space. And end, where n is the number of nodes. So that's how you solve this problem. Thank you so much.